So now let's look at a couple of questions where we need to apply this binomial theorem that we've been learning about to the problem of binomial expansion. So standard kind of question here. Expand the following. 2b minus 7 equals 4. And we want to use this formula that we've got up here for the binomial theorem to do this expansion. So what we should do first is make sure we write this thing that we're given here in a form that lets us easily apply the binomial theorem. And what I mean by that is our binomial theorem always has a plus sign in the middle. So we should write this thing that we have in brackets here as two things that are added to each other. And these two things are going to be the 2b and a negative 7. And we'll still have our exponent of 4 up here. So we should compare this expression we've got here with this expression up here, the binomial theorem, and figure out what our values of n, a, and x are. N is pretty easy. That's always the exponent. So n is 4 here. A is going to be the first thing in that bracket there. So that's going to be our 2b. And our x here is negative 7. And that negative is going to be important. I'm going to put brackets around it to remind you that the negative has always got to stay with that 7 there. So let's write out what our binomial theorem is here. Let's just put in the value of n, a, and x first. So we're going to have a sum, series of terms added up. K equals 0. It goes up to 4. So we're going to have 0, 1, 2, 3, 4. So 5 terms. We're going to have a coefficient out front, which is 4 choose whatever our value of k is. And then we're going to have a term that is our a value, 2b, to the exponent 4 minus whatever our k is. And then we're going to have another term, which is negative 7, to the exponent whatever k is. So we've just rewritten the binomial theorem with the given information. Now let's expand this out and write out what each of our terms are going to be. So our first term, where k is 0, we're going to have 4 choose 0, 2b to the 4, and then we'll have negative 7 to the 0, which is just going to be 1. So we don't even need to bother writing that out. Next up, we're going to have 4 choose 1, okay, because k is now equal to 1. We'll have 2b to the exponent of k minus 1. So 4 minus 1 is going to be 3. And then negative 7 to the 1. So we've got a term here, k equals 0, k equals 1. And let's see if we can fit in our k equals 2 term on this same line here. So this is going to be 4 choose 2, 2b squared, negative 7 squared. Now I got to come down to the next line here. Plus, what's next? We've got a k equals 3 term, so 4 choose 3, 2b to the 1, negative 7 to the 3, and our last term is going to be 4 choose 4. We're going to have 2b to the exponent 0, so we don't even need that term, and then negative 7 to the 4. So this is our k equals 3, and this is our k equals 4 term. So that's the binomial theorem stuff done. The next part is evaluating our combinations and expanding our expressions here. So if we look at the first term, we've got 4 choose 0. What's 4 choose 0? That's just 1. 2b to the exponent 4. We've got to remember that that exponent 4 applies to everything that is inside the brackets there, the 2 and the b. So we're going to get 2 to the power of 4, which is 16, and then b to the power of 4. So there's our first term. We still have to clean up a little bit. Our next term, we got 4 choose 1. 4 choose 1 is just 4. We expand 2b cubed, so we're going to get 2 to the power of 3 is 8, b cubed. And then we've got negative 7 to the power of 1, so we're still going to have a negative 7. Our next term, we've got 4 choose 2. 4 choose 2 is going to be, what, 6? Okay. 2b squared gives us 4b squared. And then negative 7 squared is giving us a positive 49, because it's an even exponent. Coming down to our next term, we've got 4 choose 3, which is going to be 4 again. We're going to have just 2b, and then negative 7 to the exponent of 3. This is where we have to get out our calculator, negative 343. Plus our final term, 4 choose 4 is just going to be 1, and negative 7 to the power of 4, again with our calculator, 2,401. Our final step is just going to be multiplying all of these numbers in each of the terms together to get our final coefficients. So in our first term here, we've got 1 times 16, so it's just going to be 16b to the power of 4. In our next term, we've got to multiply the 4, the 8, and the negative 7 together to get negative 224 b cubed. Our next one, we've got to multiply the 6, the 4, and the 49 to get 1,176 b squared. And just to keep this organized, I'll come down to another line here. Next term, we've got 4 times 2 times negative 343, which is not positive, but negative 2,744. Just b there, though. And our last term is just going to be a constant term, 2,401. So that is our binomial expansion. So a lot of practice working with the calculator there, fortunately. Okay? So this is a somewhat complex one because we got the negatives in there, and we got a whole lot of expansion and multiplication to do. Okay? So the way to get good at this, do a few examples and try them out. Okay? Our last question, the second kind of question here is, rather than being asked for the entire expansion, they ask us for a single term from the expansion. So here they're asking us for the 6th term in the expansion of x cubed minus 2 to the power of 9. I think we should start this one the same way we started the last one. Take what we're given here, x cubed minus 2, and rewrite it so it looks very, very similar to this thing that we have in our binomial theorem here. So I'm going to write this as x cubed in brackets, that's like our a, plus negative 2, that's like our x, all to the power of n. So when we write it like this, we know right away n is 9, that's our exponent. We want to replace a in our binomial theorem with x cubed, and we want to replace x, let's make an x here, with negative 2. And again, I'm going to put that negative in brackets there to remind us that that negative has got to stay with that 2. We could go and write out the entire expansion, or we could just ask ourselves, if we're interested in the 6th term, what is the value of k that corresponds to the 6th term? Well, let's see. For the first term, k equals 0. For the second term, k equals 1. For the third term, write that a little neater, third, k equals 2, and so on and so on. So if we want the 6th term, what is k going to be? is going to be 5. It's going to be 1 less than this number that we've been using to identify the number of the term. Okay? So k equals 5. Now we know what each term in our binomial expansion is going to look like. A single term is going to be generated by that expression right there. The part that comes after that sum symbol. Just underline it in red here. So each term is going to have that form. So we want to just take our value of n, our value of a, our value of x, and our value of k. So n, a, x, and k, and put them into that formula. So our sixth term is going to be 9, choose 5. I said 5, but I wrote a 6 there, right? Because our k value is 5, our n value is 9. A, which is x cubed, to the power of n minus k. So if n is 9 and k is 5, exponent 4. X, oh wait, and then negative 2 to the power of k. So that's just that n choose k, a to the n minus k, x to the k. And then from here, we just need to evaluate what's going on. Using our calculator, we can do 5 choose 9 to get 126. X to the 3 to the power 4. From way back in grade 9, we know that we need to multiply the exponents. X to the power of 12. And then negative 2 to the power of 5. We know that 2 to the power of 5 is going to be 32. Is it going to be negative or positive? Let's see. We've got a negative base. We've got an odd exponent. So we're going to have one negative sign left over. This is going to be negative 32. And then we multiply the negative 26, the 26 and the negative 32 together. Negative 4,032 x to the power of 12. That would be the sixth term in the expansion of x cubed minus 2 to the power of 9. And that's all we need for our final answer.